Hello friends, this is Aditya Sharma and welcome to the tutorial on the process table and process control block. Before heading into the topic, let's understand what topics we'll be discussing in today's tutorial. We'll start with understanding what a process table is, followed by the process states in the operating system. Then we will understand the process control block along with a flowchart and a diagram. Further, we will discuss the necessity for process control block and understand the significance of the process scheduler. Now let's begin the tutorial with understanding what a process table is. The process table is basically an array of process control blocks that logically contains a PCB for all of the current processes in the system. To identify the process, it assigns a process identification number to each process. These PIDs are stored in the process table. The PID numbers reflect the status of the process inside the process control block, whether it is in running state, ready state, blocked state or suspended state. Now let us discuss about the process states. The process from its creation to completion passes through a minimum of 5 states. The names of the states are not standardized, although the process may be in one of the following 5 states during its execution. The set of states are ready state when a process is newly created, running state or the processing state, followed by the blocked or waiting state, which comes into encounter if any interruption occurs or any input or output is awaited. Then comes the completion or termination state, reflecting the process is terminated after successful completion. Sometimes a process may get into suspended state when a process is in ready state, which is moved to secondary memory from the main memory due to the lack of resources. It is also called in suspend ready state. The next topic in the bucket list is process control block or PCB. While creating a process, the operating system performs several operations. As the operating system supports multi-programming, it needs to keep track of all the processes. For this task, the process control block is used. To track the process's execution status, each block of the memory contains information about the process state, program counter, stack pointer, status of the opened files, scheduling algorithms, etc. When the process makes a transition from one state to another, the operating system must update the information in the process's PCB. The process control block stores the register content, also known as execution content of the processor when it was blocked from running state. Now let us understand the entities involved in the process control diagram. Firstly, we have pointers. The operating system maintains pointers to each process's PCB in a process table so that it can access the PCB quickly. Then, as discussed earlier, the process state stores the respective states of the process. Then comes the process number. So basically every process is assigned with a unique ID known as a process ID or PID, which stores the process identifier. The program counter stores the counter which contains the address of the next instruction that is to be executed for the process. Register is a very fast computer memory. It is used to store data or instruction which is in execution. The memory limits are the field containing the information about memory management system used by the operating system. Finally, the open file list information includes the list of files opened for a process. The last topic in today's tutorial is process schedulers. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. There are major three types of process schedulers. The first one is long-term job schedulers. It basically controls the degree of multiprogramming, that is, the number of processes present in the ready state at any point of time. Further, it is important that the long-term scheduler make a careful selection of both I/O and CPU bound processes. The job scheduler increases efficiency by maintaining a balance between the I/O bound and CPU bound processes to reduce the operational time. Then comes the short-term schedulers. The short-term schedulers only select the process to schedule. It doesn't load the process on running. Here is when all the scheduling algorithms are used. Here, the dispatcher is responsible for loading the process selected by short-term scheduler on the CPU. A dispatcher performs set of tasks like switching context, switching to user mode, and jumping to the proper location in the newly loaded program. Lastly, we have medium-term job schedulers. It mainly does swapping of processes. Not only it reduces the degree of multiprogramming, but also it is helpful in maintaining a perfect balance between the IO bound and CPU bound processes. Before ending this tutorial, let's summarize the topics that we have discussed today. Firstly, we discussed about process table that basically stores the IDs of each and every process, and corresponding to it, it stores the pointer pointing to its PCB. Then we discussed about 5 basic states that included ready state, running state, blocked state, completion state, and suspended state. Further, we discussed about the process control block that contains information about the process state, program counter, stack pointer, status of opened files, scheduling algorithms, etc. We also discussed the set of basic entities in the process control block in detail and discussed about its necessity. Later, we discussed the three major process schedulers, that is the long-term, short-term and medium-term job schedulers. Thank you for watching.